Hello everyone, welcome to Science Prodigy. So today we will be beginning with the graphical analysis of motion and continuing with motion in 1D. Graphical analysis of motion, we will be mainly dealing with the different types of graphs. Now for the different types of graphs, most importantly, first is the distance time graph. Then next is the velocity time graph as well as the acceleration time graph. We will be generally considering questions on all three of them, and what does the slope of an ST graph give us, what does the area of a VT graph provides, what does the slope of an AT graph, what does the area of an AT graph gives us. So we will be looking forward to all the questions based on graphs and how to analyze the graphs very carefully, like converting an ST graph to a VT graph, VT to AT graph. All these conversions and every minute details will be covered in this session. Okay. If we start with the ST graph, that is the distance time graph or the displacement time graph, we will find that, for example, if this is the ST graph, okay, so in this particular case, if we see that the distance, what does this ST graph imply? That the distance is constantly increasing with respect to time. Maybe the distance is from origin and the distance is constantly increasing with respect to time, because it is a curve which is in the upward form, and most importantly because it is linear, means S is proportional to T in this particular graph, as we can see. So the distance is linearly increasing with respect to time from the origin position. Now if we see the particular slope of this ST graph, suppose it reaches, if I consider this point as y2, okay, and this point is x2, y2. This is the coordinates of this particular point, x2. x2 is this one, and this coordinate is 0, y2. Okay, so this is the x2, y2. Now if we see the particular triangle which I have actually formed, the area which is enclosed by it with the particular x-axis or the time axis, and then I see, we will find that this y2, if we calculate the slope, what is slope? Slope will be y2, that is the final y coordinate minus the initial y coordinate, which is 0 here. So y2 minus 0 by the final x coordinate, which is x2, minus the initial x coordinate, which is 0. So the slope is y2 by x2, this by this. So this particular slope gives me the value of velocity. Now what is this particular y2? The value y2 is this one, which is this measurement y2. So y2 is nothing but s. If we see, this is the y2 coordinate, which is nothing but the value of the distance which has been moved by the particular object, and the x2 coordinate is the particular time frame that has been taken, and s by t is nothing but the velocity. If it is the displacement time graph, it will be the velocity. If it is the speed time graph, if it is the distance time graph, then it will be the speed. So first important point is that the slope of ST graph gives velocity or speed. Okay. So this is what we can observe, that the slope is giving the velocity or the speed. Okay. So this is the general idea which we can see we have to go for y2 minus y1 by x2 minus x1, because as I said y2 and x2, this is s by t, which is nothing but velocity or speed depending on the type of graph. So this type of thing will only be asked, or they will ask that what is the distance moved in t is equals to 4 second, t is equals to 6 second. That means we have to see that if this is t is equals to 4, then what is this value, what is this corresponding s value for t is equals to 4. And in this way certain questions related to the graph or outside means the velocity part may be asked. Okay. Now moving forward to the VT graph. Now if we begin with the VT graph, first of all VT graph can give us two types of input. First is we can see that the area of the VT graph is nothing but V into T. Upon calculating the area, we will be actually calculating the V into T value, which is the S value, that is either the displacement or the distance, or if we go for the slope of the VT graph, this particular slope value will be actually delta V by delta T if we do y2 minus y1, because on the y axis only we have to plot V, and on the x axis always we will be plotting the time. So y2 minus y1 will be delta V and x2 minus x1 will be delta T. So as a result the slope will be the value of acceleration. So as a result of that, if we see, we can obtain two things. We can obtain the distance from a VT graph, we can also obtain the acceleration from a VT graph. Now the VT graph can be of various types. For example, to analyze a VT graph, to understand a VT graph is the first priority. Suppose it has been given that this particular graph is a straight line. Now how to understand what this particular graph implies? Let's see this. The V value is totally constant. How constant? Because even if the time is passing, if we see this value, this point, at this point V is this value only. So for better reference, if I consider it to be 10, V in meter per second, this one in second, if I take the SI value. Now V is 10 in this case, time was 1 second. For better understanding, now if I see time is 2 seconds, V is still 10. So time is constantly increasing, right? So but as time increases, V is remaining constant. V is remaining constant and the value is equal to 10. What does that mean? That the body has a constant velocity. The body is actually not accelerating, neither decelerating, it is maintaining a uniform velocity. Uniform velocity means not just in magnitude but as well as in direction. So it is totally in the form of a straight line motion or a rectilinear motion, provided it is maintaining a constant magnitude of that particular velocity. So velocity is constant. So it is straight means velocity having this value. Even if time is passing by, velocity is remaining constant. Now if we see the other case, another VT graph, suppose this sort of a VT graph, very common sort of a VT graph, we can see that the velocity is increasing, but because it is a straight line passing through origin, we can understand that the velocity is linearly increasing with respect to time. Means as the time is also increasing, velocity is also proportionally increasing. Why? Because if I see these values, in this case when time was 1, V was something around 2. When time was 2, suppose it is just a supposition, time was 2, V was 4. When time was 3, V was 6. So it is linearly increasing. So the value of V is like this. It is linearly increasing with respect to time. That is why if you see the slope, V by T, 2 by 1, 4 by 2, 6 by 3. Ultimately all the values give the same thing, right? So V is totally consistently increasing. The increase in V is also the same, that is the delta V value is also same, right? So from this graph also we can go for finding out the slope. The slope will be nothing but acceleration. This is the graph of uniform acceleration. Why uniform acceleration? Because V is uniformly increasing its speed, and uniformly increasing its speed means the delta V is constant. So when delta V is constant, the acceleration is constant, because delta V is occurring, V is increasing, there is a delta V for the same interval of time, but acceleration is constant because this value is remaining constant for a given time interval. So delta V is remaining constant, V is increasing, but the gap of increase remains the same, which makes acceleration uniform acceleration or constant acceleration. Like if we see in this example only, delta V is 2, 6 minus 4, again the same thing, 2, and if I again increase it, 8 by 4, again same thing. So it is a constant delta V which is shown by the particular graph. So if I go for delta V by delta t, that is y2 minus y1 by x2 minus x1, this gives me the value of acceleration, that is this coordinate. We can consider it like a triangle. For these two, if I want to measure y2 minus y1, 8 minus 6, x2 minus x1 divided by 4 minus 3, which is nothing but delta V by delta t, which gives me the value of acceleration. If I want to consider for a bigger triangle, suppose this triangle, then it is 8 minus 4 by 4 minus 2, and in this way we can take any other triangle for our reference to find the value of acceleration. So we have already seen that delta V by delta t gives me acceleration, and this is the particular graph of velocity being proportional to t, as well as the graph which shows that this is a constant acceleration or a uniform acceleration, because acceleration is remaining constant. Now it is a uniform acceleration because the value of delta V is acceleration we are calling, because delta V is positive. Now if the graph looks something like this, downward, it had a constant velocity, some velocity initially at t is equals to 0, just at t is equals to 0, it had some constant velocity. This velocity is increasing linearly as time is also increasing. So because velocity is linearly decreasing, that means this is the graph of decelerating motion. Or we can also consider it to be the graph of uniform deceleration, because it is a linear graph. So this is obviously a uniform deceleration or uniform retardation, okay. So because it is uniformly decreasing from a constant magnitude at t is equals to 0, it is uniformly decreasing with respect to time. Now we can see one more graph. Now there are these sort of graphs which are totally non-uniform, like this sort of. That means the velocity is ultimately increasing but not directly increasing. The velocity is increasing, the increase is a bit less over here. Again it is tending to be constant because it looks a bit straight. Again it is increasing very slowly, the slope is not much, again it is increasing, and in this way it is occurring. Ultimate observation is it is increasing but not uniformly. At certain places it is increasing too much, at certain places it is increasing a bit less. That means delta V is not constant. So it is a non-uniform acceleration or a not constant acceleration. A variable acceleration can be observed in this particular case. Okay. So now talking about the area of the VT graph. For simple thing, if I see the area of this particular VT graph, this is the graph. So the area is always with the x-axis. So if I draw the perpendicular over here, the area of the VT graph, this VT graph is nothing but a right angled triangle. So the area of the VT graph is nothing but V into T, which is nothing but the displacement or the displacement or the distance, and this will be given by the area of the geometrical figure, which is here just the area of the triangle, which is half of V into T. T forms the base and V is the height over here. So half of V into T. But now if it is in the form of a rectangle, like it is a constant velocity. Okay, so if I consider this as a shaded region, the area of this particular graph, this area will be the area of a rectangle. So the area, which is the distance, will be nothing but the area of the rectangle, which is V into T. But now if the graph is actually given in this form, like a trapezium, I am just naming the vertices. So again the area of this particular VT graph will give me the distance or the displacement depending on what is taken on the y axis. So this area is only the value of the displacement, and for the trapezium, this is a trapezium, and for the trapezium the value of the area will be giving me the value of the displacement, which is half into sum of the parallel sides into the distance between them. Like suppose this is the perpendicular distance between them into AD. Okay. So this is the area of this particular trapezium. This area of the evaluated trapezium is nothing but the distance or the displacement which has been provided over here. Now if I actually see one thing, if we are asked to analyze the motion of that particular object whose graph has been given in this figure, we can see that first of all the object started from a velocity 0 because it is touching the origin. So it started with initial t is equals to 0, the velocity was also 0. Then the velocity was uniformly increasing. That means it was a constant acceleration, uniformly increasing, and after reaching a certain maximum value, this velocity reached this certain maximum value, this velocity was constant till the point B, till this particular time frame. So from this particular time t1 to this particular time t2, the velocity remained constant. There was no more acceleration observed in the body. Now after reaching the time t2, when it was at the point B, it started decelerating or retarding with a uniform retardation, such that finally it again reached the velocity 0 at a time t 3 seconds. Okay. So this is how we can even analyze the motion from the VT graph, and if asked, the respective area of the figure will be the actual calculation for the distance or the displacement of the graph. Now if we go for the AT graph, the acceleration time graph, the most important thing is first one, acceleration is constant with time. So what is the inference from this graph? Acceleration is constant or uniform. Now, when the acceleration is constant or uniform, that means the delta V is constant. Delta V is constant means what? There is a uniform increase in velocity, means the velocity is not increasing very much or the velocity is not decreasing too much. There is a uniformity in its increase for a certain time interval. For this interval, this much increase in velocity means for the next same interval the same increase in velocity. So uniform increase in velocity. Right? So this is what we can actually see from this particular graph. Now if I am actually finding the value of the area of the AT curve, we can actually see that V is equals to U plus AT. So it is very much clear that the area of this AT graph will be giving me the velocity. So if we are asked to find the value of velocity from the AT graph, we can directly go for the area of the AT graph, which will give us the velocity. The area of the AT graph, if I actually go for a simple nomenclature, we will see that the area of the AT graph is OC into OA square units. This is nothing but the velocity of the particular body, which we can actually calculate from the AT graph. Now if it is asked in this way, that what is the, that draw the velocity time graph from the AT graph. This AT graph is provided and you are asked to draw the VT graph from this. If we see the VT graph from this one, from this graph, acceleration is constant. We are asked to draw the VT graph from this particular AT graph. So if acceleration is constant, so delta V has to be constant. So we must increase linearly or we must increase uniformly with respect to time. So this is the curve, that VT curve from AT curve is, it is increasing uniformly with respect to time. So this is the same thing, only the same type of motion which is represented from both of them, represented by both of them, that the velocity is increasing constantly with time, that is it has a constant acceleration which can be evaluated by calculating the slope of the curve, which is shown by this AT curve. But now if it is given that the AT curve looks like this, AT acceleration is constantly increasing with respect to time, then how will the VT curve look like? Okay, so acceleration is increasing, means delta V value is also increasing, because delta T must remain constant the same time interval where we are studying. So if I write acceleration as delta V by delta T, I can see that acceleration is uniformly increasing. That means delta V value is also uniformly increasing. So this time it won't be a straight graph, delta V will also increase. So it will be of this type, means V is exponentially increasing with respect to time. So this is how the particular VT graph will be obtained in this particular case, because V is exponentially increasing, because delta V must also increase, means V2 minus V1 and V3 minus V2, if I do, V3 minus V2 must be greater than V2 minus V1, because delta V is increasing, the difference will also increase. So this value V3 minus V2 will also increase, so it is increasing at a very faster rate in a very small interval of time. Means from this time to this time only it has increased this much, but from this time to this time means it is also not of this type, it will be even more curved, means of this type, totally increasing in the upward direction only. Okay, so I hope you understood till this part. So I will be ending this session with one particular question. The question is this. This is a distance time graph and it has been given that the distance is increasing in a parabolic fashion, like a parabola. So is it in a uniform motion or non-uniform motion? Now, if I see that it is not covering equal distances in equal intervals of time, means for this particular time frame the distance covered was less, but now for this particular time frame which is lesser, we can see that a huge amount of distance has been covered, again more distance, so the distance is not uniform, means it is not moving uniformly, so as a result it shows a non-uniform motion. So with this I end this particular session. Next I will be coming up with more questions, mainly the questions numericals on graphs, conversion of graphs from AT to VT, VT to ST, how will they look like if we convert the graphs, calculations and finding out certain values which are asked from the graphs, and more in detailed graphical analysis video will be there, so that totally detailed graphical analysis can be done by all of you, so that you can understand a graph very clearly, very minutely just by looking at it. So I will be trying my best in the next one or two videos to complete that in a wholesome manner, so that each and every little detail is covered, so that the entire analysis, the entire detailed analysis of graphs is totally done in a very detailed manner, covering every possible important types of questions to clear the concept. So till then, keep on studying, keep on learning, keep on practicing, and thanks for watching. If you are still not subscribed, do subscribe the channel. I will be covering every chapters of physics, chemistry and mathematics for your class. Thanks a lot.